My name is Mark Dunn. I'm not up here to lecture you. We're here to have kind of an involved discussion. I'm gonna present some material to you, but I expect that you know some of this. So, when I ask a question, if y'all don't give me a response, you know what's gonna happen to me? What? Not like that. I'm just gonna be quiet until you give me something. So, y'all help me out. Today we're here to talk about, will somebody say it out loud?
Left turning tendencies.
Why do you say your head like this when you say that?
Because I was shaking my head because I was looking for a pair of notes, some notes earlier.
A pair of notes?
Yeah,
So
really
notes
a
come
pair
in
of
twos? There we go. All right, so left turning tendencies. Our objective today is to help describe those left turning tendencies. And so in this, so left turning tendency, we're not going to talk about NASCAR, right? Go fast, turn left. But it's kind of like that. The faster we go in all of these maneuvers, the more left turning tendency we're going to have. You're looking at me like you're just confused this morning, Ellen. No, we're good? Okay. So we've got 4 elements today. Torque, P factors, spiraling slipstream, and gyroscopic precession. That's a big long word, so we're going to save that until the very end. So in airplanes, lift to me equals magic, right? Yes? It's magical when you get off the ground. So with lift, what produces that lift in our aircraft? Bueller. What is it?
Our wing.
Wings. Okay, how many wings are on an airplane, theoretically? Or type of wing structures? 3, 2. Anybody else? At least 4. Any other answers? Maybe 6 or more, so they need to be let in, so that we lock. So I'll draw a simple stick figure here. This is our airplane, and we're going to say it has 2 propellers.
You don't
So
need to be in.
if this is 1 and this is 2, somebody else said a bigger number. What was it? 4. What would the other 2 be? What? Come on, you got to talk louder than that. I've got big boys. The what?
The back end.
Okay, what do they call them? We got 2 things back there on the back end. Maybe these? What are they called? Say it loud, loud. Elevators, all right. Maybe there's 5 and 6 up here. What are those? The propellers, because y'all were in here for Mr. Walker's talk the other day, right? What did he talk about? Guys, what do y'all got in those bottles? Is it just water with downers or something? Bigger voices. So yes, we've got wings that we all recognize as wings. Our elevator back here acts as a wing. It's just upside down. Its camber is in the opposite direction. But our propeller acts as a wing also. So that's what we're going to be talking about in all of these, is our propeller and how it affects, you can say it out loud with me?
Left turning tendencies.
Left turning tendencies, correct. All right, so we're going to start out with torque. We're going to draw our first aircraft up here. I don't laugh at my artistic abilities, but all right, so what direction does our propeller turn if we were sitting behind it looking out the windscreen? What was that? Clockwise, all right. You might even know what clockwise is anymore because we all wear digital watches and all that stuff. But yes, clockwise. So it's going to be turning in, I'll give me a different colored marker, in a clockwise rotation. So, torque, the definition of it is a turning force about an axis. You may give me a description here. So I've brought our airplane engine, is represented by this drill. This is going to be our propeller shaft, okay? So somebody's going to grab this for me. All right, there's your propeller shaft. We're going to be rotating that in a clockwise direction. I'm looking at the windscreen, right? You're going to hold it tight? I don't want to hurt your arm.
Okay.
So it's a rotational force about the axis. So what's happening? If this is our aircraft, the body of our aircraft. There's our propeller. What is it doing? Twisting in what direction? Say it out loud. Come on, Ben, I know you talk louder than this at home. It turns in a counterclockwise direction, so we've got our engine or the propeller wanting to turn clockwise. Our whole aircraft is wanting to turn in a counterclockwise direction. That's thanks to our old friend who? Newton. You know, I think he was a lawyer or something, because he's come up with a lot of laws, right? And what is his third law?
Every
Y'all say it together in tandem?
Every action has an equal and
Opposite
There we go.
reaction.
So this is our action. What was this?
Opposite reaction.
Opposite reaction. So, with that, on an aircraft, when it's sitting on the ground, if we were looking at it, you're looking down the nose of it. Basically, the engine is turning clockwise. This aircraft is wanting to turn counterclockwise, right? But we're on the ground. Big deal. What it's going to do is load up, if you will, our left gear over here, our left wheel. And so there's more drag here, correct? Because we've applied more friction there. And so our propeller is wanting to pull us forward. Well, if we've got more drag on our left side than the right side, what do you think is going to happen? What are we talking about today?
Left turning.
Left turning tendencies. How do you think we counteract a left turning tendency? What's our friend back here?
Rudder.
Rudder? What would we use?
Right rudder.
Right rudder. Yeah, that is something we're going to write on the board in red. Right rudder. Because, Bailey, you've been in the left seat. Have you ever been screamed at about this?
Yes.
What did they say?
It's a hard right rudder.
Say it out loud.
Hard right rudder.
Is that as loud as they said it to you? Yeah? Okay. We'll take it at that. Right rudder. As a student, I'm telling you, the first time you get in the aircraft, you're used to just getting in your car, putting your hands on the wheel, press the gas pedal, and off you go in a straight line. Because you've got a lot of mass about that car, it doesn't have tons of torque in there or anything else wanting to turn our car. But in an aircraft, very lightweight, we've got a huge engine up here as compared to its weight, and so this airplane is wanting to do that. Your instructor will say it over and over and over.
Right rudder. Right rudder.
There we go, right rudder. All right. So, on the ground, like we said, it loads up that left gear. What do you think happens in the air? Anybody? I'm going to just move up here. We'll get a little closer to you. What is this? We have 3 axes in an airplane. What is this? Pitch.
Roll.
There we go. So if we're flying along and we've got all this torque going on and it's wanting to roll the aircraft counterclockwise, what are we going to be doing? Banking left. Yes. Okay. So on the ground, drag on that left gear in the air. We're going to be banking. We counteract on the ground, right rudder in the air. It might be a little more roll to the right. All right. So moving on down to P factor. We've covered torque. Move on down here to P factor. We're going to draw another aircraft. Now, who was here for Mr. Walker's talk about the propellers? Yeah? Then maybe y'all can come up here and teach this as well. So, P factor, get over my notes here. It's the airplane's propeller up there. We talked about wings, right? What were these up here? Propeller blades. So they're in essence a wing, right? So, when you're sitting in straight and level flight, both of these blades or wings up here are grabbing the same amount of air, causing the same amount of thrust, correct? As y'all remember about the pitch on those blades? But whenever we go to ascend, we've changed what? I'm going to give you a hint up here. So I know y'all know this. What does that stand for? Angle of attack. So, these blades, and I'll find a propeller up here because I just saw one a while ago. Somewhere, here we go. That twist on that blade. So, if we've got this blade coming down, this is our descending blade, right? Because it's turning in a clockwise direction. Straight and level flight, both of these blades are at the same angle, right? But if we go to pitch up like this, now you're looking at it from the left-hand side. This blade's almost straight up and down, correct? What about this blade over here? A lot more angle of that, because here we are coming straight on. You see the angle of that blade? So, our ascending blade, like we said, is relatively flat. Our descending blade over here has a lot more pitch to it in the direction of flight, correct? Y'all seeing that? So if we're looking at that, this side of our prop is going to be creating just a little force. This side, more so. Because of that, we're going to have a lot more thrust of wind under this wing, just a little bit, under our left wing. If this right side of the propeller is creating or grabbing more bite and thus creating more force, what do you think is going to happen to the aircraft?
Gonna turn that direction?
Turn what direction? Give me a hand.
Left.
Left. Why? We've got so much more force coming on the left side of the aircraft here. Grab a red marker so that we'll highlight these. Lots of force going under the right side. We'll shorten those areas to represent less force over here because we've taken a smaller bite on our ascending blade. Is that making sense? Okay. So, because of that, we have this left turning tendency going on, and in flight, what do you think is going to happen to that aircraft? We've created a left yaw because of the bigger bite over here, correct? But if we're putting more air under this wing, what do you think is going to happen? Gotta say it out loud.
Roll.
There we go. So on the ground, we're going to have left turning tendency. In the air, we'll get a little bit of that roll in as well. How do you think we counteract that?
Right rudder.
You gotta say that loud. You're an instructor.
Right rudder.
You're almost an instructor.
Right rudder.
There we go, right rudder. That's gonna be our mantra of the day. Right rudder, right rudder. Kinda sounds like a mouthful when you said it out loud like that. All right, so on to our third one here, spiraling slipstream. Now this one's kind of fun in that, what direction did we say our aircraft engine is turning, or our propeller?
Clockwise.
Clockwise. I know we're saying that over and over, but you kind of got to get it in the back of your head for all of these to make sense. All right, so here again, we've got our clockwise turning engine. So with that propeller turning to the right like that, what's happening is a slipstream of air is created, impacting where back here? What surface is that? Or what? It's correct, back what?
Vertical stabilizer.
Vertical stabilizer. It has what you said attached to the back of it. Or what?
The rudders.
There we go. Two or one? Two?
Rudder.
It has two rudders?
Rudder.
It's a rudder. You have two rudder pedals. You have one rudder. I got snapped on that in class. But you've got this slipstream going around the aircraft. So I've given you a demonstration of that. Here's my little trusty V-tail with a wonky propeller on it. Our propeller's turning in this direction, right? Clockwise. So it's created this slipstream of air going around it, impacting on the rear surface. On mine, it's not a vertical stabilizer, but same intention here. It's pushing on the tail of the aircraft. So you're facing forward. We've got this slipstream of air going around it. Pushing here, what does that do? What's that?
Y'all.
There we go, y'all. In these texts, you gotta say yaw instead of y'all, it sounds like y'all. But yeah, it's pushing the tail of the aircraft, so it's giving us a yaw, which results in a what?
Left turn.
Left turning tendency. So, man, we've got a lot of stuff all happening at the same time here. We've talked about torque. It's causing us to what? Turn left. Our P factor is causing us to what?
Roll.
Well, it's also yawing
Yeah.
and a little bit of roll, you're correct. And now we've got this slipstream that's also has this yaw effect. How do you think we counteract that? Say it out loud?
Right rudder.
Come on, y'all are gonna be instructors one day.
Right
The
rudder.
guys in our first class were so, like they were out there on the football field or something. All right, right rudder. So the way that works, yeah, just make sure we're intact and in touch with our surfaces here. So if we're wanting to yaw, this is what? On the very back of it?
Stabilizer.
Or what?
Vertical stabilizer.
And what does it have on the back of it?
Rudder.
Here we go. So if we pushed on the right rudder, what do you think is gonna happen to this plane back here? What direction will it turn? This direction or this direction? It's only two guesses. 50% chance of being wrong. Go ahead. This direction or this direction?
Left.
There we go. Which is thus gonna make us turn this way? Is that the way we wanna go?
No.
No, which way do we wanna go?
Left.
So we push our right rudder. Remember? Right rudder, right rudder. So, anytime we have that left turning tendency or that left yaw, right rudder is gonna straighten us out and keep us on down the runway. Now, I want you to think about this. As you start off down the runway, it's not, you know, mom or dad driving the car. How many of you started driving? Yeah, some? So when you're at a stoplight, what do we do with the gas pedal? This, or do we do this?
Ease it.
What's that?
Ease.
Ease it in. Same thing on an aircraft. When we're sitting there on the end of the runway, we don't just, oh, all right, light the fire. We want to ease it in for a couple of reasons. Number one, it's harmful to the engine for you just to shove everything forward. It's nice and cool, and all of a sudden you're going to just create spark, and man, temperature's going to rise. You're going to see your meters just pegging out. So we want to ease the throttle in for that reason. And then also, if we just shove that throttle in, what do you think is going to happen to the airplane? We've already talked about what?
Torque. P factor.
And now in this one, that's 3 times. I mean, we've got exponential here. We've got 3 forces going on that if you're just shoving the throttle in, where are we going to wind up? I mean, if this is our runway and we were headed down the center of it, and this is about the proportion, where do you think we're going to wind up? What's that?
Go into the,
I don't speak yawn. Let's say it one more
go
time.
into the field, start turning to the left.
Turning to the left, being out here in the giggly weeds, busting lights and asking for the line guys to help pull you out. And now they've got the traffic pattern full and you've caused a mess down there. So, 3 things so far that have caused these left turning tendencies. The last is a little different. We're gonna again draw our aircraft up here. One more time.
He's getting pretty good at that airplane drawing.
It may take off and fly here in a minute.
See that.
One more time. What direction is our engine turning?
Left.
Left, right, what?
Clockwise.
Clockwise, there we go. Still turning clockwise. And so, we've got something called gyroscopic precession. Anybody ever seen or played with one of those gyroscopes? You ever seen one of those? Pull the string and that little thing spins in the center? I had one out in the car and I swear I'm gonna go grab it for the next class, but I came prepared with something else. This is my propeller, okay? Let's all pretend. So what direction are we spinning? I'm sitting up behind it. All right, we're gonna spin clockwise. And there's a physical law that would take me pages and pages and pages saying stuff that I don't really understand. But I believe it because science works all the time, whether you believe it or not. Gravity works, right? I jump up, I'm gonna come down. But this rule says that if you apply a force to a gyroscope, and our propeller is in essence a gyroscope, it's a spinning disc. If we apply a force, it will be felt, generally speaking, 90 degrees in the direction of its motion. So our propeller is turning what direction?
Clockwise.
Clockwise, and if I apply a force here, where's it gonna be felt?
90 degrees to the right.
Over here. So this has more of an effect on tailwheel aircraft. So I want you to think about this. Tail wheels, and let's just, pretend this front wheel's off up here. We've got a wheel on the back. They sit like this on the runway, correct? You've seen those guys, and they don't have much of a view. You don't have a tail wheel right. So when you taxi, and you've got to do these S-turns because you can't really see over the windscreen, you're just giving it this. And when they get out there on the runway, they're still tail down. Well, again, how fast are we pushing that throttle in? Fast or slow?
Slow.
Just easing it in. So we start this roll, and when it generates enough wind speed underneath the surfaces, first thing they're going to want to do is pitch forward. That seems a little counterintuitive. You're wanting to go up in the air. But we've got to get that aircraft level first, or the tail up, in order to get wind under all of the air surfaces before they can finally pull the stick back and take off. So, with this big disc up here, the first force is basically going to be as though I were pushing my finger. Here's my propeller. It's leaned back in a direction. I'm basically going to want to push here for that propeller to be straight up and down, correct?
Mr. Dunn, can I stop you?
Yes.
Just a second.
Please.
Hang on. Let them put their stuff
That's
away.
okay. Gives me a minute to caffeine up.
All right, there you go. Bye. Y'all have a wonderful day. I'm glad you'll see you on Saturday.
They don't just fly their drones in and land them on the shelves and take off.
Hey, that's a good idea.
All right, so we understand the principle then with tail wheels. They're tail low, taxiing out. They're going to pick that tail up when they're rolling down the runway so that we get level. And then finally, they're going to rotate up. So we're going to give this thing a quick spin. This is a bicycle wheel off my bike. All right, so we're sitting here. We're going to take off, and as I nose up, what's happening? What's that?
It's turning left as the left turn.
Why do you think that is? Yeah? Because we're pushing here basically to get that propeller forward, right? And the effect is felt where? 90 degrees in the direction of its rotation. So again, we'll get it spinning. We go moving. Man, so what's that going to do? Where's that going to put us on the runway? In the grass. Is that where we want to be? Lord help knows. So, with our airplane over here, we never did put the tail wheel back here. There it is. There's our forward wheel. So as we pick up on the tail back here, we're applying a force, in essence, at the top of the disc, the top of that propeller, right? The spinning disc. Where it's felt is 90 degrees later. And what's our tendency?
Turn to the left.
A turn or a yaw, correct?
Yaw.
Yeah, so it's wanting to yaw us. And like I said, this is predominantly felt in tailwheel aircraft. When you've got a tricycle gear, we're running pretty much straight down the runway level. And when we go to pitch up, we've already got a lot of forward momentum going. Because there's another law out there that says the body in motion what?
Stays in motion,
There we go.
on my
Yeah, so we've already got this strong motion going in a forward direction. So that now when we go to pick up, we'd be doing just the opposite, right? We'd be pushing on the bottom of this. It actually causes us a little bit of right, which is now fighting the other three of these, so they kind of balance out once we're up off the ground. Does that make sense? Okay, so we've talked about torque, P-factor, which is not what Grandpa has when he drinks too much coffee, right? Spiraling slipstream, where's the windmill or the windstream effect that goes around the aircraft? Or excuse me, that was our torque. Here's our spiraling slipstream back here, impacts the tail. And then finally, the gyroscopic precession. Any questions on those so far? We're good there? Okay. So, what's the mantra we want to keep in mind?
Right rudder.
Right rudder. Okay. So, conclusion to all of this, little horsepower, what? Little bit of all of these, right? That's why in trainers, we start off kind of small with just a little bit of horsepower, a little bit of thrust, so that we don't have to overcome all these huge forces, because guess what? You go jump into a larger aircraft, you move from 120, 140 horse to now over double that, 300, 400 horsepower. These factors all increase exponentially, so you've got a lot more of that to deal with. So when we go to the gym and it's leg day, what are we gonna work on?
Right.
Right leg. Y'all just do, one leg dips and one leg presses. And then just keep in mind, always right rudder when you're flying. I mean, you would impress your instructor if the very first time you get in an aircraft, just let them know, say, hey, I'm gonna make sure and apply a lot of right rudder, or compensate for. And if you named off even 2 of these 4, they're gonna get wide-eyed and go, holy cow, you're a genius. Make sense on all of these?
Yes, sir.
All right, so I'm ready for your questions. What are they? Surely there's 1 or 2. So it's just the last class that was really smart? Y'all like, ooh.
Good morning, Hudson Middle School. Please stand for your pledges.